To the viewers, we now discuss analytic functions of complex variable, and that's for the specific idea we discussing here, the part limit. Now limit of complex variable. We consider a function phi be defined at all points z in some deleted neighborhood or deleted NBD of Z0. Then we have limit as z tends to Z0 phi of z, that will be W0 equals to, or equivalently phi z tends to W0 as z tends to Z0. That means if we consider it analytically, for each positive epsilon greater than 0, there is a positive delta such that mod of phi z minus W0 is less than epsilon whenever mod of z minus Z0 less than delta. This is the analytical definition, and this definition is same as we consider in real analysis, and that is, and here also we consider W tends to, that is if we consider here phi z as W, writing as in the earlier situations we consider phi z, that is a value of phi at z if W, that is limit z tends to Z0 W, that will be W0. Here W equals to phi of z. If we consider in this way, then we can write it, that is W minus W0, that will be less than epsilon whenever mod of z minus Z0 less than delta. So we complete our definitions. If we given some of the pictorial representations, but here it is a complex variable, so we needed here two pair. One pair is x and y, because in every complex variable that can be written in the form of x plus iy. So one terms we consider here z and Z0, that can be written in the represented in the form of in the plane xy, argon plane, which is basically not a real plane. So here we draw a figure, and we know in complex shape that is a disc shape type of a circle. So now here we are considering type of a circle. Center will be Z0, and here if we are considering another point, say Z, and already we know that the radius is delta, this radius. This is our geometrical representations in xy plane, and it is another consideration of UV plane. Alternatively we are doing it here. If we draw a figure in cases of UV plane, and here we also consider, then if we draw same thing, that's W0, and here if we consider here W, no matter for that, and here the radius is epsilon. So it is our pictorial representations and geometrical interpretations we draw in this way of the limit of function. That is the general cases of limit of a function and definitions. Now we end our discussions regarding the limit for the topic of analytic function of complex variable part 2. If you like the video, like it, share it, subscribe the channel. Thanks for watching.